Alright class, we take the second application of Newton's third law of motion, which is what we call the recoil of a gun. It should be noted that whenever a gun is fired, the momentum of the gun is always equal to the momentum of the bullet. Whenever a gun is fired, the bullet coming out from the nozzle of the gun is equal to the momentum of the gun. From here, we have momentum of the gun equals momentum of the bullet. And we know that momentum is mathematically defined as the product of the mass of a body and its velocity. So from there, we have mg/vg equals mb/vb. Making our vg some of formula, we have vg equals mb/vb all over mg, where vg is what we call the recoil velocity of the gun. mb is the mass of the bullet, vb is the velocity of the bullet, mg is the mass of the gun. From here, we take example number 1. A machine gun of mass 20 kg fires a bullet of mass 100 gram due south with a velocity of 250 meters per second. What is the recoil velocity of the gun? Class, before we solve the question, take note. The gun and the bullet will move in opposite direction. Whenever a gun is fired, the bullet will move in opposite direction as the gun. So we are saying if the bullet is moving southward, the gun will move northward. If the bullet is moving eastward, the gun will move westward. From the question, we have the solution. Mass of the gun mg equals 20 kg. Mass of the bullet mb equals 100 gram. And we said in physics, we must convert all parameters to their basic units. The basic unit of measurement of mass is kg. And here we are given 100 gram, which must be converted to kg. 100 gram to kg will give us 0.1 kg. That is 100 divided by 1000. So from there, velocity of the bullet vb equals 250 meters per second. The recoil velocity of the gun vg is the unknown. What is the standard and basic formula for that? We have our vg equals mb/vb all over mg. From there, we have 0.1 times 250 all over 20. And that will give us 1.25 meters per second due north. Why do you have due north? Because the bullet was fired due south. Good morning, class. We take the concluding part of the applications of Newton's third law of motion, which is rocket and jet engine propulsion. Take note, class. The thrust experienced by rocket or jet engine is equal to the product of the rate of ejection of the gases and the velocity. The thrust, which is the force that a jet engine or rocket will experience when fired, is equal to the product of the gases, rate of gases ejected, and the velocity. So from there, we have our thrust equals rate of gases expelled multiplied by the velocity. Rate means mass per time. Rate of gases expelled is mass per time. So we have mass per time multiplied by the velocity. From there, mathematically using symbol, we have mv all over t. So we are saying the thrust, which is the force that a jet engine or rocket will experience, equals mv all over t. Let's take an example. A jet engine develops a thrust of 270 Newton seconds when the velocity of the exhaust gases relative to the engine is 300 meters per second. What is the mass ejected per second? We have to find m per t. From there, we write out all the given parameter. The thrust equals 270 Newton seconds. The velocity v equals 300 meters per second. Now, class, what do you think will be the suitable formula to use to solve this question? And that would be thrust equals m per t multiplied by v. The thrust, we put the thrust value there, 270 equals to m per t times 300. We make m per t is our formula. That would be 270 divided by 300 equals m per t. When we divide, we have 0.9. Therefore, our m per t equals 0.9 kg per second. Thank you.